and that was to provide cushioning during a gear-up landing. This would fully retract, thus reducing drag and improving range. And moving forward to the nose wheel, which was upgraded to be steerable from the cockpit. The B-29 simply had what was called a castering nose wheel, and while this was simpler and lighter, the crew could only turn with differential throttle and braking. This made takeoff challenging, as the throttle response wouldn't be immediate, and they would need to be going fast enough before the rudder could be used to steer. The B-50 crew could simply adjust the nose wheel to steer.
Yeah, so something really interesting here. They mentioned how those turbojets that were out on the wings, that they were the same one that were in the Sabre, F-86 Saberjet. Saberjet also had a steerable nose gear, because obviously when you only have one engine, there's no way to do differential thrust. And you basically would land and have to wait for somebody to come get you. But it's interesting that at similar times they were retrofitting these things onto the B-50. It was pretty good.
Here's a B-29 nose wheel for comparison's sake, and you can see that it appears far less complex. And back to the B-50 once again. Now this disassembled aircraft at the Plane of Fame Museum in California is special because it's actually Lucky Lady 2, which was the first plane to fly around the world non-stop. It was refueled 4 times over the Azores, Saudi Arabia, Philippines, and then Hawaii by KB-29 tankers. It took 94 hours and 1 minute, landing on March the 2nd, 1949.
Yeah, Peachy, differential thrust is, you can see how the engines run, from both sides of the aircraft. You can slow one side down or speed one up, and that'll give you differential thrust, so you can turn. It's done in the air, it's done on the ground. It can actually be a heck of a thing if you lose an engine.
Sadly, this aircraft was disassembled after an accident, and here's what's left of it. And highlighting the rapid advances in aviation, just 7
Dang, look at that thing.
years later, the B-52 would also fly around the world non-stop, but in less than half of the time.
Looks way less impressive as a
It is
tube.
the only B-58 left anywhere in the world, and I'm sure they'd love donations to help restore it for display. There was a reconnaissance RB-50 fitted with high-altitude photography equipment, and some were fitted with systems to detect Soviet defensive equipment such as radars. These would run ferret missions where they would provoke a Soviet response and then measure their radar and listen to the radio messages to learn more about how the Soviets would respond. The B-50 could fly higher than any Soviet World War II fighter, but the arrival of the jet-powered MiG-15 changed that dramatically, reducing the safety of these flights until the B-47 arrived. In fact, it was one of these that was the only B-50 variant to be lost in combat. In 1953, an RB-50G was shot down near Vladivostok by 2 MiG-17s. Sadly, only the co-pilot survived. A weather reconnaissance version called the WB-50 replaced the older WB-29s. It could fly higher, faster, and longer than its predecessor, and was fitted with Doppler radar and other equipment and extra fuel tanks.
Now, as far as being shot down in combat, even the B-47 never really saw combat or was shot down. They pretty much lost all of their airframes to training accidents, so that's pretty impressive.
It was used to fly classified missions to obtain atmospheric samples to detect if the Soviets were detonating nuclear weapons in the early 1950s. This was also used to monitor the weather around Cuba to help plan photo reconnaissance flights during the Cuban Missile Crisis. It was eventually
Oh man, look at that cartoon mushroom cloud in the background. These people had some fun.
replaced in this role by the WB-47. The EB-50B was modified to test the bicycle undercarriage.
What the? They put tank treads on an airplane? Jeez. That must have been some expensive tank treads. My gosh.
Later used on the B-47 and B-52, and was later used to test a Caterpillar track landing gear. This had the benefit of spreading the weight over a larger area, which was useful on grass, or if the plane was just incredibly heavy, as we saw with the B-36. But the belts just couldn't operate fast enough for landing and takeoff, so the idea was scrapped.
Yeah, no crap.
Of interest, a track system was considered on the B-36 as well, but didn't make it in production.
I mean, if you look at like how small these wheels are, and you think about how fast an airplane's wheels have to go as soon as you land in order to speed up and actually get rolling resistance under control without just self-detonating, yeah, I can understand why the belts didn't work.
It could carry 20,000 pounds of bombs internally and 8,000 pounds on external hardpoints, although there were modifications made for the 40,000 pound T-12 Clad Maker bomb.
Now, if I could find those treads at a surplus store, I would buy them in a heartbeat. It'd be hilarious. It'd be the only aircraft-rated tank treads ever.
Conflicting information if it was installed in a B-29 or this, but either way...
My gosh, that's a big bomb.
The bomb bay was also regularly modified to fit different atomic bombs as they went into production, and you can see it sitting over a bomb loading pit here. The B-50 was also used to test drop multiple atomic bombs over the Nevada test site in the late 1940s and early 1950s. This view of the bomb detonating from this altitude really is awe-inspiring and terrifying at the same time. You can see mention of Test Atomic Group painted on the side of the fuselage of this aircraft here.
I don't think I'd want to be airborne next to that bomb going off. Jeez.
In addition to dropping the bombs, it also flew through the atomic cloud, and with equipment attached to the fuselage, they would measure the fallout. These would follow the radioactive material for hours after the detonation, measuring the intensity and spread. After that, they would wash any radiation particles off the aircraft, as you can see here with this B-29. It was also used as a mothership for the Bell X-1 high-speed research plane.
Heck yeah.
It was the first piloted aircraft to exceed the speed of sound in level flight, with famed test pilot Chuck Yeager on board, and the first of the X-planes, which were a series of experimental aircraft flown by the USA to explore new technology.
I think I remember the scene in The Right Stuff where, you know, Chuck Yeager's about to get in the plane and go for the test flight, and he's like, hey, you got any Beemans on you? This type of gum. But that's pretty hilarious. That's a B-50, my gosh.
It also carried the Bell Jam 63 Rascal, which was the USAF's first standoff air-to-ground nuclear missile. It was cancelled, but initially designed to be launched from the B-50 amongst other aircraft.
It's not a missile, that's a fighter jet without a pilot. Jeez.
This refueling KB-50 was retired in 1965 after corrosion was discovered as contributing to a crash in Thailand in 1964. They were all replaced by the jet-powered KC-135. Now, unfortunately, I couldn't film inside this aircraft, although the interior was much the same as that seen inside the B-29, and I'll link to my video crawling around that aircraft, also here at the Pima Air and Space Museum.
Yeah, and I looked in the cockpit of that B-50, not the B-50, the Guppy that was in Oregon, very similar flight control layout and instruments.
In Tucson, in the video description below. But back to the B-50, and the number of crew would depend on the configuration, but they all had at least 2 pilots, a navigator and a flight engineer. A bombardier radio ECM operator was added to the regular version in addition to multiple guys to operate the turrets. The refueling versions would have 2 refueling operators, and the weather and reconnaissance versions also had extra crew to operate their various systems. Now it's worth mentioning what would have been the ultimate superfortress, but sadly never made it further than a mock-up, as you can see.
B-54? Whoa. What the heck is that? Is that a big radar down there?
60 variable discharge turbines. The fuselage was lengthened by over 10 feet to make the atomic bombs fit in easier, and the wingspan was extended by 20 feet. The wing was so wide now, in fact, that they had to install outrigger wheels in the first and fourth engine nacelle. Much more fuel would be carried, thus creating a longer range. You can certainly make out that it's related to the B-50, but it's worth mentioning some of the additions that you can see in the photos. You may recall that the Superfortress's front cone has a lot of glass, but also a lot of frames which would obstruct the gunner's view, so this hemispheric sight was installed. They could sit comfortably still and look into this eyepiece and get an unimpeded view from the outside. There was one positioned both at the front and at the tail of the aircraft. The gunner's hand grip would move both the gun and the scanning prisms inside the sight's head, so the bullets would fire directly to where the gunner was looking. These would work in conjunction with the radar system in the dome below. Here's a B-52D, and you can see a similar sight, although it's far less obvious.
Interesting.
In 1948, the USAF did place orders for this aircraft, although it was eventually cancelled as it became evident that newer jet-powered bombers were going to be vastly superior. It seems that the Strategic Air Command boss, Curtis LeMay, wasn't a fan, and he preferred the B-36. Now I know that this is a B-29 and not the 50, but it's a fascinating photo of the two together and highlights just how massive the B-36 is. The last B-50 was delivered in March 1953, and a total of 371 were made. The reality was that it was only ever a stopgap before the next generation of jets arrived and went on to dominate military aviation. While the B-50D was removed from bomber service in 1954.
I mean, just like most airplanes, that are the last of their kind, obviously this was probably the state of the art when it came to propeller-driven bombers from the United States. So, pretty dang awesome. I'm glad that the Soviets copied the B-29 and not this thing.
Reconnaissance versions continued on until the arrival of the B-47. Weather recon and refueling 50s continued into the 1960s and replaced by the WB-47 and KC-135 respectively. The final flight was in 1967, and this is the very same aircraft now retired at the USAF Museum in Dayton, Ohio. The Superfortress really was an incredible aircraft, with the B-29 being designed during the worst of World War II and first flew in 1942. Then later versions went on to operate during the Korean and Vietnam Wars, as well as the Cold War. It really was a versatile and fascinating design, and a credit to the engineers who designed it and the brave men who flew in it. We often get caught up with the fascinating engineering that goes into these birds and forget the incredible sacrifice made by the thousands of airmen lost during conflicts throughout the world on board these. If you enjoyed the video, then please give it a thumbs up and comment below with your thoughts about this fascinating aircraft.
I think that's what we'll do. Pretty dang awesome video. Anyways, that was one of the cool ones I thought was worth watching today. Let's see if we can find another one. Oh yeah, one of my favorite ones, there's a guy named Sandbox on YouTube that was talking about the F-35, and they were talking about supersizing it or something like that. They found the designer of the YF-23, which was better than the YF-22. Go ahead and argue it out in the comments if you want. But let's go ahead and watch that video.
Lockheed Martin scrolled across the side of its fuselage, with Boeing defeating the stealth fighter powerhouse to secure the Air Force's new air superiority fighter contract, and then the Navy eliminating Lockheed from the running for its own currently uncertain stealth fighter efforts. But the firm behind both the F-22 and F-35 is not going quietly into that good night, and has instead proposed a bridge fighter, something that spans the technological gap between today's most advanced tactical jets and the capabilities brought to bear by this new generation of fighters in the works. In fact, according to Lockheed Martin CEO Jim Taiclet, they believe they can port many of the advanced technologies developed for their sixth-generation fighter effort over to the F-35, making something of a fifth-and-a-half-generation Frankenfighter that he says can deliver 80% of a sixth-generation fighter's capabilities for just 50% of the price. But what exactly?
That's what they say. They're going to have to completely redesign the darn thing. Maybe they can keep the nose forward. I mean, keep it forward at the main bulkhead there behind the pilot, but to even be close to competitive in the Pacific, they're going to need some serious range.
Exactly might such a fighter even look like? Well, fortunately for us, Graham Warwick at Aviation Week recently published an incredible interview with Daryl Cummings, the designer of Northrop's legendary YF-23, breaking down a very logical approach to modifying today's F-35 for tomorrow's battlefield, borrowing directly from past Lockheed efforts like the F-16XL and tailless Raptor designs like the X-44 Manta. And the results are, well, pretty promising. So let's go over the analysis work of Warwick and Cummings and inject a little context along the way to help us better understand what this fifth and a half generation F-35 might really look like, what it could be capable of high-profile scandals, and Lockheed Martin holds the distinction of having already fielded the most capable and most advanced stealth fighters that this world has ever seen in the F-22 and F-35. And while
Heck yeah.
lightning never strikes the same place twice, just a few weeks later, it did, with the Navy also announcing that Lockheed Martin had been eliminated from the running in their own new stealth fighter competition, commonly known as FAXX. Now that means that in the years ahead, Lockheed Martin will still have plenty of fighter orders to fill with its ongoing F-35 program. But as Boeing pumps out advanced new F-47 stealth fighters and Northrop Grumman continues production on advanced new B-21 stealth bombers, Lockheed's Joint Strike Fighters will no longer be the crown jewels of their respective air forces, as the callous march of time sees today's most advanced tactical aircraft give way to that legacy title.
We'll say Kelly Johnson had 14 rules for how to do business, as a defense program, and one of those rules was don't do business with the Navy. So we'll see how this one works out.
Or, to put it another way, as a new generation of stealth aircraft comes online, the F-35's unmatched combination of stealth, sensor fusion, and onboard computing power will not only be matched, they'll be exceeded. And before you know it, we'll begin to see the F-35 in a similar light to how we think of advanced fourth-generation fighters today. Aircraft that are certainly still capable for a wide variety of operations, but that are ultimately second-string players behind a new starting lineup of advanced tactical and strategic platforms. But this is the company that built America's first jet-powered fighter in the P-80, the fastest crew jet in history in the SR-71, the world's first operational stealth aircraft in the F-117, the world's first stealth fighter in the F-22, and the most widely operated stealth aircraft of all time in the F-35. F-117, the world's first stealth fighter in the F-22, and the most widely operated stealth aircraft of all time in the F-35. They have no intention of taking these setbacks lying down. And as we've discussed on this channel before,
Now the F-35, I've heard them flying around compared to F-16s. They're really loud, and people are like, why are they so loud? And I'm like, it takes a lot of power to make a pig fly. Thing is a beast.
just about 1 month after Boeing's NGAD contract victory was announced, Lockheed's CEO Jim Taiclet set his new plan into motion, announcing his proposal for a, quote, Ferrari overhaul on the F-35 chassis that would include improved sensors like an advanced new radar and infrared targeting capabilities, improvements to the fighter's stealth delivered via new, quote, techniques, materials, design geometries, and countermeasures, and new long-range weapons tied to those advanced new sensors to ensure this new F-35 can take out its opponents long before they ever have a chance to fire back. I'll quote Taiclet directly now. It's like a NASCAR upgrade, so to speak, where we could take the F-35, apply some of those co-funded technologies, both from NGAD and the F-35 program, and you're gonna have, again, my challenge to my aeronautics team is let's get 80% of 6th gen capability at half the price. That's something that these are engineers. They wouldn't have agreed to this if they didn't think there was a path to get there.
Sounds like a salesman. I don't know. Sometimes when they make promises like this, we'll see what happens.
That's something that we're going to go out and do. Now, since then, Takelet has added to his argument in favor of this new Ferrari F-35 by pointing out that it's likely going to take at least 5 years. But
Wait, I thought he said it was NASCAR. What the? I don't want a Ferrari. You can't drive a Ferrari every day. It'll die.
But more likely 10 to see the F-47 actually enter service in appreciable numbers. Takelet believes Lockheed can field its advanced new F-35 much faster than that, with those upgraded F-35s then providing an asymmetric and deterrent advantage over advanced Chinese jets like the most modernized J-20s and the forthcoming J-35, all while also addressing some of the shortcomings F-35s currently.
What about the J-36 and the J-50, huh? Those things are pretty impressive too.
Would have in a Pacific fight, like their unrefueled range. Now, the per unit price of the F-47 has yet to be disclosed, but previous estimates presented by Air Force officials have placed it potentially as high as $300 million per airframe, which I know sounds like a fortune, but is actually pretty in keeping with previous top-tier fighter efforts once we've adjusted that cost for inflation. At 50% of that price point, these overhauled F-35s would then probably ring in at around $150 million each, which is
Ugh, it's still not cheap.
about $67 million more dollars than today's F-35A, which rings in at around $83 million. And with that roughly 81% increase in per unit price would come a dramatic increase in technological complexity and, more importantly, capability.
Now, one benefit you'll find with aircraft like this is if they're already in production, there's a production line, there's a workforce, there's engineers that know what they're doing with regards to fighters. I mean, if you could augment the F-35 production line, we're basically making 4 variants. What, the A, B, C, and then whatever the heck the Israelis get, because there's a lot of mods to that one. What's another one? Sure. Yeah, just make them the same factory. More tooling.
But what might those capabilities actually look like? Well, about 3 months ago, I posted a video breaking down the improvements that I thought were technologically and financially feasible for such an effort, starting with a baseline of the forthcoming Block 4 overhaul, and then looking to other programs that could be ported to this new F-35, like the new infrared search and track targeting system and stealth underwing fuel pods being developed for the F-22 Raptor, adding adaptive cycle engines like GE's XA-100, and finally, to a newly reshaped tail, new control surfaces, and even new wing layouts to provide a substantial increase in lift, payload, and range akin to similar Lockheed programs from the past, like the F-16XL and FB-22.
Yeah, the airplane should have been in production. That was the best version of the F-16.
But thanks to Aviation Week's Graham Warwick, you no longer have to settle for my take, and we can instead turn to a real expert, Daryl Cummings. Now, for a lot of you out there, that might not be a very familiar name, but if you're a fighter fan of any sort, you will all but certainly recognize his work. Mr. Cummings, who now serves as the president of an aircraft design consulting firm called Fors Aero, has made such significant contributions to American aerospace that it can be tough to overstate. During his time as a configuration designer for Boeing and Rockwell prior to the merger, between 1967 and 82, he worked on early stealth efforts, the B-1 bomber, and the groundbreaking Advanced Fighter Technology Integration program that led to now industry standard breakthroughs in automatic terrain following radar, triple redundant fly-by-wire systems, helmet cued targeting, and a whole lot more. In the 1990s, Cummings led the development of Boeing's X-40A Space Maneuver Vehicle Demonstration Aircraft, which, again, you may not be familiar with, but I bet you have heard of the platform Boeing was able to build as a result of his X-40A successes. Today's highly secretive X-37B long-duration spaceplane. But Cummings' most famous and popular work came during his stint at the Northrop Corporation when he served as chief configuration designer for the fan favorite YF-23. That's correct. He was the designer behind the only fighter in the world to have a really legitimate claim at outperforming the F-23.
Black Widow.
In fact, Cummings' YF-23 design was so forward-leaning that elements of it even appear to be alive and well in Northrop Grumman's recently released render of its 6th generation FAXX.
Now, he's the chief configuration engineer. I don't know if that, leads to like saying, hey, he's the one that actually designed the whole thing. There's a whole bunch of engineers like that. We know for sure on the B-2, John Cashin was regarded as the person who came up with the plan form, the shape of the aircraft. Be interested to know if this guy is the one that came up with that or not for the YF-23.
Design for the Navy. Suffice to say, there are few people on this planet more qualified to opine on how the F-35 could evolve for the future of warfare than Darrell Cummings. And I'm relieved to the wing area. The second is to use thrust vectoring to eliminate the tail. Now, before we go any further, we should take a quick minute to discuss what Cummings means by fineness ratio, because that may not be a common phrase for those of us who don't design fighter jets for a living. In very simple terms, the fineness ratio of an aircraft is the ratio of its fuselage length versus the fuselage's maximum width. Or, in other words, it's a measure of how long and slender or how stubby your fuselage is. A higher fineness ratio or a more slender fuselage can improve supersonic performance, while a lower fineness ratio or a stubbier fuselage can often benefit low-speed maneuverability, as an example. Of course, as in all things aircraft design, there are pros and cons to increasing and to decreasing that fineness ratio.
Yeah, like being able to take off from an aircraft carrier.
So finding the right balance is vital. Most modern fighters today land somewhere between, boasting fineness ratios that are above 10 and 11, respectively, on the F-35. I'll quote him again. The short length of the F-35, combined with the fuselage cross-section necessary to contain weapon bays and landing gear, contribute to a poor fineness. That carrier-capable F-35Cs much wider 43-foot wings, but positioned aft on the fuselage to the rear of the aircraft. Further forward, he places a new set of canards for pitch 5FX would rely purely on a three-dimensional thrust vectoring engine nozzle.
Pretty cool.
And an advanced computer fly-by-wire system to provide pitch, roll, and yaw control. Then this upgraded F-35 would also boast a much larger clipped delta wing planeform, providing a huge increase in internal volume for added fuel and larger payloads. According to Cummings' math, this design would allow the fighter to carry a whopping 30,000 pounds of fuel on board, which
Starting to look kind of like a tailless F-35, kind of like what Northrop proposed back during the JSF competition.
he undersells as a 50% increase over the F-35A, but by my math, would actually be more like a 62% increase. Though, maybe he meant the F-35 in bigger cost in terms of money, time, and resources. So how much would it cost, and how long might it take to get one of these heavily modified F-35 designs into service? Well, we're going to have to work with some guesstimations and extrapolations here. Unfortunately, the non-recurring costs of standing up F-35 production have not been overtly identified, and based on contract awards, it would seem that those non-recurring costs have been broken down across production lots, making them easier to stomach, but also harder to divine. In other words, we don't know exactly how much it costs to stand up production on the F-35 because
That's in Palmdale, Building 401.
those costs have just been rolled into later purchases. So instead, we can look to the F-35's older sister, the F-22 Raptor, for some pretty loose back of the envelope
I'm just going to say trillions. Oh yeah, that's how much the F-35 costs, trillions.
type figures. F-22 production was halted in 2011 after just 187 Raptors were delivered. And contrary to my long-standing belief, the fighter's tooling was never actually destroyed. Instead, it was all moved into long-term storage at the Sierra Army Depot in Herlong, California, though much of the rest of the fighter's production infrastructure was cannibalized to benefit the F-35 program that was still underway. Then in February of 2017, the U.S. Air Force put together a then classified report into what it would cost to restart Raptor production. And we can use some of their findings to help inform our own cost estimates for changing the F-35's production infrastructure in order to build Cummins' new F-35 designs. Although the goal was just to restart Raptor production, the Air Force report and the RAND report that preceded it both acknowledged that some of the fighter subsystems would still need to be redesigned to suit modern production and operational needs. In particular, the jets, they just in major subsystem for a total of $5.8 billion in 2016 money, which at our current rate of inflation would shake out to around $7.91 billion today. Now, chances are good that a Ferrari F-35, like those Cummins has designed, would also leverage a new engine, namely GE's XA100 or Pratt & Whitney.
Now, if it was $7.9 billion, it would still take at least 5 years to make a prototype. I don't see them going any faster than that, but maybe a couple years they could shave off.
XA101, both of which were designed to fit in the current F-35A and C, but would nonetheless require design work to integrate. Likewise, all three of Cummins' designs would require a massive overhaul of the F-35's flight software, especially the more sophisticated FX and GX designs that omit some control surfaces in favor of more advanced thrust vector control.
I just use AI. What could go wrong?
And while this new I think it would be safe to say that the extent of the design changes to the aircraft would at least match the cost of simply revamping the F-22's design. Now, once the design's been hashed out, up next would be creating the new tooling, or all the equipment, jigs, fixtures, molds, dies, and templates necessary to mass produce these new fighters. According to the Air Force, the Raptor's original government-furnished equipment tooling cost roughly $1.1 billion to produce back in 1997, or about $2.23 billion today. Then they assumed a fair portion of that tooling would need to be refurbished after being pulled out of storage for an estimated cost of around $228 million, or around $310.89 million in 2025. So with that all in mind, tooling for Cummins' least aggressive changes in the F-35EX would likely land somewhere between those two figures, but maybe closer to the lower one, as it would retain the most F-35A and C components. The more sophisticated F-35FX would probably land somewhere closer to the higher end of that spectrum, and the F-35GX, which departs the most from the original design, could potentially exceed that $1 billion mark for tooling alone.
Yeah, we'll just say none of these options are cheap. Just need to pick one and start moving. Aircraft take a long time to design, long time to develop, partly because they have to be secret. And when you're secret, you're slow. So, yeah, if we use ChatGPT to design a fighter jet, could go good. But we could also hand over the designs by accident quickly. Oops.
Now, with the tooling complete, the next challenge would be the requalification of subcontractors and vendors who would be tasked with producing entirely new components for this new F-35 design. Now, some of this would be much easier work. 5 suppliers are all probably already complying with federal acquisition regulations, already have existing supply chains, and wouldn't need to start the whole evaluation process over again. But verifying supplier production capabilities, quality management, and certification of new components would 100% still be necessary, and in a lot of cases would probably even require site visits and inspections. The F-22, which had roughly 1,000 subcontractors and vendors involved in its production, was projected to cost about $1.2 billion to complete this process, which is about $1.64 billion today. The F-35 program, on the other hand, has nearly twice as many vendors and subcontractors, around 1,900, and would be undergoing significant changes rather than just coming out of dormancy. So we'll just keep that figure where it is and call that even. And finally, the Air Force anticipated roughly $1.5 billion in general government costs associated with standing production on the F-22 back up, which is about $2.05 billion. Audits, regulatory compliance, support, documentation, technical oversight.
And we'll just say all these numbers could get bigger or smaller because it's the Navy instead of the Air Force. They don't use the same standards. This could be really interesting, but the degree to which they could reutilize the F-35 design, very interesting idea. Worth having, but if they use the C variant, it won't have a cannon because only the A model has that.
Site, logistics, overhead, and everything else you can come up with. And this is where things get a little more complicated. If the plan is to modify existing F-35 production lines to build new F-35